Hey everyone, and welcome to This Explainer. I am absolutely pumped to guide you through today's topic, because we are looking at a truly monumental shift in the world of generative media. We're talking about the battle for cinematic machine intelligence in late 2026, and let me tell you, this landscape has transformed way faster than almost anyone predicted. We're going to break down exactly how the tectonic plates of this industry have shifted, leaning on a really fantastic technical review from TekinGame Media to help us make sense of it all.
So to understand where we are right now, we kind of have to look at how we got here. Back in mid-2026, the industry got hit with a massive structural vacuum. Out of nowhere, OpenAI made the totally unexpected strategic decision to sunset and fully decommission its Sora platform, deciding to redirect all that capital toward dense reasoning architectures instead. And that left a colossal gap in the creative AI market. The whole viral novelty phase of early AI video was officially over. Suddenly, the enterprise world was left looking around asking, okay, who is actually going to step up and fill this void with a real industrial-grade utility?
All right, let's dive right into this. Here's our roadmap for today. We'll be covering the post-Sora vacuum, the new document-to-video engine, achieving 30 seconds of coherence, audio-visual synthesis, slashing the price tag, and finally, the global AI rebalance.
Let's start things off with Section 1, the post-Sora vacuum, and how a new contender emerges.
In the immediate fallout of Sora's exit, the battlefield narrowed down to an elite tier of foundational models. You had Google DeepMind pushing super aggressively to cement Western dominance with their deployment of Veo 3.0, but then Chinese cloud and AI titan Alibaba Group dropped Wan 3.0, or Tongyi Wensheng 3.0. And listen, this was not just some minor iterative update. No way. This was a paradigm-shifting pipeline engineered from the ground up to ingest complex enterprise collateral. It signaled an immediate, aggressive shift in the global creative computing hierarchy.
Which brings us right into Section 2, the document-to-video engine, basically killing prompt engineering.
For years, the absolute biggest bottleneck in AI video workflows was complex prompt engineering, right? Creative directors, marketing teams, they were literally forced to manually distill these massive, dense documents into super fragile, syntax-heavy text prompts. It was tedious, and honestly, it usually resulted in really disjointed visual transitions. Well, Wan 3.0 completely eradicates that friction. It embeds a specialized multimodal document understanding layer straight into its pipeline. You literally just upload a 20-page product white paper in a PDF, an executive pitch deck in PowerPoint, or even paste a live e-commerce web URL. The vision language model automatically parses the semantic hierarchy, pulls out your brand design guidelines, and generates a fully orchestrated cinematic storyboard all on its own. It's an absolutely frictionless multimodal translation, and it is a total game changer for enterprise production.
Moving right along to Section 3, 30 seconds of coherence and breaking the time barrier.
Generating stable video over a sustained 30-second window has always been one of the toughest computational hurdles in machine learning. Older models would just collapse into surreal warping and physical impossibilities after maybe 5 to 10 seconds, mostly due to catastrophic noise accumulation, or what we call noise drift. So how do they actually solve that drift? Let's bust some jargon for a second. Wan 3.0 achieves something called temporal identity consistency. Basically, these are latent space feature locking algorithms that preserve the exact same facial geometry, clothing textures, and lighting environments across extended sequences. Because of this tech, Wan 3.0 hits a record-breaking 92.8 out of 100 identity retention benchmark score across complex multi-angle transitions. Structurally, it just stays permanent. To pull off that crazy level of temporal consistency, Alibaba is running a massive neural architecture under the hood, specifically a 3D spatiotemporal variational autoencoder paired up with an 18 billion parameter diffusion transformer. I know, that's a mouthful. In simpler terms, rather than treating a video like a 2D flipbook of images, it actually conceptualizes the frames as a continuous 4D space-time environment. That means real-world intuitive physics, stuff like gravity, fluid dynamics, light refraction, and even cloth inertia, are deeply embedded right into the model's cross-attention mechanisms.
And because the model inherently understands that it's in a 3D environment, the precision it offers is just unreal. It brings in this advanced director-level camera control suite using 3D Cartesian spatial trajectory mapping. Creators can dial in incredibly complex cinematographic camera paths. We're talking tracking shots, panoramic sweeps, vertical crane movements, dolly zooms, and full 360-degree orbital rotations. You can do all of this through intuitive natural language instructions or precise vector coordinates, which gives visual effects studios some serious, reliable cinematographic power.
All right, let's explore Section 4, Audio-Visual Synthesis, sound that actually matches the vision.
Because, let's be real, visuals are only half the cinematic experience, right? One of the crowning technical achievements of Wan 3.0 is its end-to-end integration of auditory and visual generative modalities. It programmatically builds out a comprehensive, studio-grade 48 kHz stereo soundscape that is perfectly synced with whatever is happening on screen. We're talking dynamic, genre-appropriate musical scores, contextual Foley sound effects, like imagine footsteps on wet cobblestone, distant thunder, or an engine revving up, all mapped to exact millisecond timestamps. And if there's spoken dialogue, the model handles phoneme-level lip synchronization across dozens of global languages, mapping microfacial muscle dynamics with absolutely pristine realism. It's wild.
Now, we pivot from this remarkable technology to an equally disruptive business reality. Section 5, Slashing the Price Tag, the New Economic Reality.
Historically, enterprise adoption of generative video tools has been completely choked by massive GPU compute costs. But the global pricing matrix has totally shifted. Check this out. Google DeepMind's VO 3.1 sits at roughly 35 cents per second. Specialized Western platforms like Runway Gen 3 hover around 40 cents per second, and that's for a max of 10 seconds. Alibaba's Wan 3.0, on the other hand, it is priced at just 15 cents per second for a full 30-second duration at 1080p. They're aggressively undercutting the Western incumbents, quite literally slicing prevailing market rates in half.
To put that economic efficiency into perspective, $4.50. That is the total infrastructure expenditure required to produce a complete, broadcast-ready, 30-second commercial reel on Wan 3.0. Compare that to $10.50 on VO 3.1 or upwards of $12 on Runway. This radical cost reduction completely unlocks high-volume automated video generation from millions of small and medium enterprises all over the world.
Now, this aggressive pricing isn't magic. It is hardcore engineering. As Dr. Zhang from the Cloud Economic Structure at Alibaba Group puts it, democratizing video creation requires aggressive infrastructure optimization. By delivering broadcast-quality synthesis at half the prevailing market cost, Wan 3.0 transforms generative cinema into an everyday enterprise utility. Basically, through proprietary CUDA kernel optimizations and highly distributed memory scheduling, they've unlocked a completely new commercial feasibility.
Which leads us to our final section, Section 6, the global AI rebalance and the macro-level geopolitical shift we're witnessing.
The structural vacuum that Sora left behind didn't just change the tech, it accelerated a much broader geopolitical shift in frontier computing. Asian AI enterprises, notably players like Alibaba, Kling, and Minimax, are swiftly moving in to fill that space. And neutrally speaking, they are setting the new global standard for computational efficiency, rapid multimodal feature integration, and highly accessible commercial pricing. They are prioritizing architectures that actually solve real-world enterprise needs at operational costs that businesses can actually sustain.
To really sum up the state of the market, the Applied Media Intelligence Council at TekinGame notes something super profound. They state, "The generative video sector has matured beyond the era of viral novelty into an industrial utility. Ultimate market leadership belongs to architectures providing structural permanence at sustainable operational cost." In other words, future competitiveness relies entirely on multi-minute narrative stability and real-time pipeline integration. The novelty phase is over.
And that is exactly what Alibaba has pulled off here. Over on the TekinGame strategic scorecard, Wan 3.0 earns a massive 9.6, officially labeled a multimodal masterpiece. The core takeaways of this explainer are pretty clear. By pioneering native document-to-video ingestion, ensuring 30 seconds of rock-solid physical stability, and introducing massively disruptive pricing, Wan 3.0 has delivered an indispensable creative platform that fundamentally democratizes global storytelling. So, that leaves us with this vital final thought to chew on. We are no longer waiting around for the future of AI video. The industrial utility era has officially arrived. Now that broadcast-grade generative video is literally an everyday $4.50 enterprise utility, how will you rewrite the rules of digital storytelling? Thank you so much for joining me on this explainer today. I really hope this deep dive has given you the structured clarity you need to understand exactly where the creative computing landscape is heading next. See you next time.